Hi, my name is Nicole Firestone from Penn State University, and today I'll be presenting on very high energy gamma ray sources detected with the HAWC Observatory. My research kind of straddles the fields of physics and astronomy, so I'm going to provide a bit of background on the astro side of my work. So when we gaze up into the night sky, we're only seeing a mere glimpse of the astounding beauty that characterizes our universe. With today's technology, we're able to explore the sky in wavelengths across the electromagnetic spectrum, from low energy radio waves to the highest energy gamma rays. On this slide, we have a graphic with images of the Milky Way. Each row is a picture of the Milky Way in a different range of energies, going from lowest energy or longest wavelength on the top to highest energy or shortest wavelength on the bottom. There's lots of exciting science that we can explore by looking at the sky at each of these energies. But personally, I find high energy gamma rays to be the most enticing portion of the electromagnetic spectrum. Gamma rays are high energy light particles, and they're non-interacting, so they travel in uninhibited straight paths to Earth. By investigating the gamma rays that reach us here on Earth, we can become acquainted with some of the astrophysical objects that reside in the most extreme conditions in this galaxy and across the universe. These astrophysical extremophiles can be anything from pulsars, which are basically super epic space jets, to gamma ray bursts, which are energetic explosions, or supernova remnants, which are the aftermath of exploding stars. By looking at the gamma ray signatures of these sources, we can begin to better understand how they accelerate particles to such high energies. One of the best detectors for these sources is the High Altitude Water Cherenkov Gamma Ray Observatory, or HAWC. HAWC is a ground-based detector comprising 300 water Cherenkov tanks. And HAWC is one of the highest energy gamma ray detectors to date. As gamma rays interact with our atmosphere, they create particle showers like this. And by tracking how a shower hits the array of tanks in time, we can reconstruct the shower and trace it back to those high energy phenomena that I showed in the previous slide. Other key advantages of the HAWC Observatory are our nearly continuous duty cycle and our wide field of view, which allow us to capture 2/3 of the sky, as you can see in this image here. With the advantages of these unique capabilities, we can conduct blind searches of the sky for new high energy sources. Over the past 5 years, we've detected many gamma ray sources across the plane of our Milky Way galaxy. But we've also discovered some gamma ray sources that have such high energies that no other observatory has seen them before. In 2017, HAWC conducted a blind search of our entire field of view. From this search, we discovered 16 brand new excesses in the very high energy gamma ray emission that resides in the plane of the Milky Way galaxy. And you can see each of those excesses marked with a little circle with a cross in it on this slide here. If you look at this zoomed in region of the galactic plane, you can see one of these newly discovered sources. Since 2017, we've been monitoring and examining these candidate sources in order to determine if we can truly consider them high energy sources or if they're just fluctuations in the background gamma ray emission. Since this detection is so new, we're still trying to model its energy spectrum and better understand what exciting type of astrophysical object it could be. But with more data from a broadband range of energies, we'll be able to constrain the source's acceleration mechanisms and one day understand what kind of beautiful astronomical phenomenon is hiding just before our eyes as we look into the night sky. Thank you so much for listening to this presentation. Please reach out to me if you have questions about my research or the HAWC Observatory, or if you have more technical questions, I would be more than happy to answer them. Thank you.